Good morning, class. The first homework for Unit 7 is just notes on dilations and similarity, the basic ideas. A dilation is a transformation that produces an image that is the same shape but a different size. So in other words, it's not a rigid motion. Dilations are described by two things: the scale factor, or constant of dilation, and the center of dilation. The scale factor is always something that you multiply by, right? It's not something that is added and subtracted. It's always, when you're working with scale factor, it involves multiplication and division only, not addition, not subtraction. Dilations result in similar figures. Similar means that all pairs of corresponding angles are congruent and all pairs of corresponding sides are in proportion. In proportion means that when you divide the image by the original, you always get the same number. When you divide the pairs of corresponding sides, you get the scale factor. The symbol for similar is just a single little squiggle called a tilde, and this, as you know, the symbol for congruent is the tilde with the equal sign. You might want to pause now to get this down. Dilations can result in different orientations. This was a mistake here, try to blot that out. If the center is within a figure, then the dilation will be around the original. If the center is on a corner, then the image will be partially overlapping. But if the center is somewhere else, you know, maybe over here or something, then the image will be completely or maybe slightly overlapping. So it's okay if you have partial overlap, or one is inside the other or one is not on top of the other. There are different orientations that can result there. Okay, depending on where the center is, inside, on, or off the figure. The scale factor is always given by the image length divided by the original length. Okay, you divide the length of the image by the length of the original. Now, if the image is smaller than the original, then you're going to get a fraction or decimal that is less than 1. And that's okay, but not a negative number. Okay, negative number would do more than just dilate. It would change the position a little bit more. All right, so you can also use, if you know the length of the original and the length of the original part of the original length of the image, you can divide those two. But you can also use portions of the projection lines to find the scale factor. It works the same way. So for example, let's say I didn't know this length and I don't know this length, but I do know this one. Right? So if say I call this y and this x, then the scale factor is y divided by x. All right, so if you don't know the lengths of the actual figures, maybe to give you a picture, but you are able to calculate these, then you can use the lengths of the projection lines, parts of the projection line, to figure out the scale factor. All right, just a couple quick notes on dilations in the coordinate plane. All right, when the center is 0, 0, and the scale factor is a, then xy just becomes ax, ay. All right, just multiply the points by the scale factor. Okay, but that's only when the center is 0, 0, which is called the origin. But if the center is not 0, 0, there's no easy formula. I mean, I could probably write one up, but it wouldn't be worth remembering. When the center is not 0, 0, you have to draw the projection lines coming off the center. And then you use your knowledge of slope and distance to kind of walk down the projection lines to find the corresponding points. So let's say my scale factor is 2. Then I'd say, maybe this is just a vertical line, so I could just count 1, 2, 3, 4, 1, 2, 3, 4. That gives me my image. But here, I'm not allowed to count on the diagonal. So here I'd have to do rise, the run and the rise. The run and the rise. So if my scale factor was 2, I'd just do the rise over the 1 twice. If it was 3, I'd go down a 3rd time. All right? So you got to walk over the horizontal and vertical distances to get to double that distance, or to go further, to triple it or quadruple it. You can even do half amounts, like what if I wanted to go 2.5 times as far. So just remember, don't count on the diagonal. You can only count vertically and horizontally. So you would kind of walk it down. If it's vertical or horizontal, you just count boxes, but if the projection line is diagonal, do the run and the rise, the run and the rise. And you double or triple it depending on the scale factor. All right, that's really all the basic ideas of dilations. The next thing will be to be dilations of actual lines that go on infinitely, and that generally just results in a parallel line. But we'll talk about that some other time. All right, have a good day.